Hey everybody, Mr. Burrell here, and we're going to do homework assignment 8.2, which covers exponential growth and decay. Now, I really think this is a pretty easy homework assignment. It shouldn't take you more than I don't know, I'm going to guess 10 minutes probably. But there are a lot of little details to remember. And so anything that's really, really important stuff to remember, I've gone ahead and put those in these boxes right here. So as you're doing your homework assignment, first of all, realize that there are questions to answer, but that those boxes are there to help you, do this assignment better. So let's just go ahead and let's not dump anything. Let's jump right in and answer these questions, which ask us to convert the percentages to decimals. Now, if you've forgotten how to do that over the last couple of years, I know you've done it a lot in past grades, I've got this bullet point right here. It reminds us that to change a percentage to a decimal, we need to take the percentage and divide it by 100. So I've got my calculator right next to me, and I know you can't see that, but I promise I've got it. And I'm going to use that calculator to do these conversions here. So for 25%, I'm just typing in my calculator 25 divided by 100. And when I push enter, I get 0.25. Now, I'm going to probably put a 0 in front of this decimal. It doesn't change the value of what I'm writing. It just makes this decimal a little more visible, just in case while I'm writing on the screen, you don't see it so well. But you're going to see that a lot with calculators or a lot of times on worksheets and things like that, just so that the decimal doesn't stay hidden. And a lot of times I'll put a 0 in front of that decimal just to really emphasize the fact that it's there. All right, 3%. Now, I know it's tempting to just write that this is 0.3, but that is not true, which is why I'm using my calculator to double check this. 3%, or so 3 divided by 100 is 0.03. Sorry, my handwriting's a little messy because my stylus is being a little bit dorky. Oh well. Okay, and then question 3 asks us for 89%. When I type that in my calculator and divide it by 100, I'm getting 0.89. Okay, cool. So for the majority of this worksheet, we're going to be looking for something called a multiplier. And the multiplier is a number that we find when we have a percentage of either growth or decay. And depending on if we have growth or decay, we have to do different things to it. So on this worksheet, I have instructions if we have growth and instructions if we have decay. I'm just going to be following those instructions right there. And, yeah, let's go ahead and do this. So if I want to find the multiplier, and I know that I have 25% growth, then I'm going to follow these steps right here. I'm going to take 100 plus the percentage. So 100 plus 25 is 125. Oh my gosh, there we go. And the reason why that is because if you can imagine, let's say that I have money that's growing by 25% a year, for example. Well, from year to year, I'm going to have 100% of my money. And on top of that, I'm going to add 25%. So if I had 100% of my money plus another 25% of my money, that means that the next year I'm going to have 125% of my money. And so 125 turned into a percent or into a decimal. So I do 125 divided by 100 is 1.25. Okay? So again, this idea that we're adding 100 is really important because I don't want to see anybody just write 1.3. Like in class, I know a lot of students were saying, oh, you just add a 1. And, well, that's kind of true in some cases, but you've got to really remember that we're adding 100%. So 100% plus 3% is 103%. Take that number divided by 100 in the calculator, and I'm getting 1.03. Same idea for 89. If I have 100% plus 89% divided by 100, I'm going to get 1.89. Now, decay is a little bit different. With decay, you're imagining something shrinking. You're losing stuff. And for that reason, we're going to do 100% minus the percentage. So let's say that I lose 25% of my hair. You want to consider how much of my hair I'm going to be keeping. So if I'm losing 25% of my hair from year to year, I started with 100, I lost 25, I'm keeping 75%. So 100% minus 25% is 75%. Turn that into a decimal like we talked about earlier, and that's going to be 0.75 for our multiplier. So 100% minus 3% is 97%. Turn that into a decimal, and we get 0. Oh my gosh, my stylus is making me angry. I'm going to try to use my finger, but it's going to get even uglier. 0.79. Okay? 100% minus 89% is 11%. Turn that into a decimal, and we have 0.11. Okay, cool. So those multipliers are going to help us write these functions here. I'm going to answer the questions on the left. Oh my gosh, and they're misnumbered. I will have these questions renumbered before I print this worksheet. So this will really be question 10, 12, and 14. Sorry for the error in this video. I promise it'll be fixed. Alright, so I have here that I want a function with an initial value of 5 and a 12% growth rate. So in class we talked about how these exponential functions, things that grow by percentages, look like this. They don't look like what we're used to. We're used to blank x plus blank for linear equations. But now we're dealing with exponential equations. So we're going to change that up a little bit, and we're looking at blank times blank to the x power. The number in the first blank is something called an initial value, or the starting value. So in question 10 it tells us a function has an initial value of 5. So I'm going to put a 5 right there. And a 12% growth rate. So I need to find the multiplier. I can't just write the number 12 there. A 12% growth rate means that we need to take 100% plus 12% and turn it into a decimal. So that would be 1.12. Oh my gosh. Like that. Okay, again, sorry, stylus, crazy. Question 12. A function has an initial value of 0.23. Okay, well that's easy. I don't need to convert anything. That one's just written the way that it is. 0.23. And then it says it has a 31% decay rate. So remember to find that multiplier since it's decaying. If I have 100% of whatever and I am losing 31%, then that means that I'm going to have 69% of whatever it is. And so my multiplier is going to be 0.69. There we go. Okay. A piece of bread began with 5 mold spores, which grew at a rate of 9% an hour. So don't forget, I'm looking for blank times blank to the x power. If it's starting with 5 mold spores, that's my initial value. It's growing at a rate of 9%, so 100 plus 9 is 109. Turn that into a decimal, and we've got 1.09. All right, let's go on to the next page. On the next page, we're going to have to think backwards a little bit. I'm going to answer questions, 13 and 18, but it's not really going to be question 13 and 18. It'll be question 15, 16, 17, 18, 19, and 20. Okay. So here, and again, I know this can be tricky, but I have all of these instructions right here. What we have is we're going to start with a function, and our job is to figure out if this function is growing or decaying, and by what percentage. In question 15, I kind of give you a hint that we are looking at growth. Excuse me, so I'm going to follow these instructions right here. Okay, so I have a function with an initial value of 1 and a multiplier of 1.25. To find the percentage of growth, because I told you it's growth already, I need to convert the multiplier into a percent. So when we converted percentages to decimals, we divided by 100. This way we're going to go backwards. I'm going to do 1.25 in my calculator times 100, so that's 125. And then what it says here is I want to take the percent and subtract 100. So 125 minus 100 tells me that this has a 25% growth rate. All right, let's come over here to question 20. And it says that we have a function with an initial value of 21 and a multiplier of 0.89. So, oh yeah, here we don't know if it's growth or decay, so I want to read this little note here on number 1. Number 1 says that we need to first find the multiplier, which we did. It's 0.89. And if the multiplier is greater than 1, then I know the function is growing. So that's how I knew when I made this worksheet for you guys that this function was growing, was because this number was bigger than 1. If the multiplier is greater than 0 but less than 1, so that's the case here, 0.89 is between 0 and 1, then this function is decaying. Once you've decided if the function is growing or decaying, we're going to follow these steps. So I know that's decay. And so here we're going to convert the multiplier to a percent. That's a lot like what we did before. I know this is decaying. Oh my gosh, decay. So 0.89 times 100 is 89%. And then here it says we're going to do 100 minus the percent. So 100 minus 89 tells me that this is an 11% decay. In other words, I know we're decaying, and we're keeping 89% of whatever it is that's decaying. If we're keeping 89% of whatever it is that's decaying, that means we're losing 11%. All right, I hope this video was helpful for you. I'm super sorry about the stylus and the questions being off, but I hope you have such a great night. Okay, bye!